What's up? Algebra 1, Mr. Ford here with a homework tutorial. This is 4.2.4, problem 71 through 76. Let's go for it. These first questions are all going to be, actually, well, this is 71 actually, but hey. These problems are all going to be practice with solving systems. They're all going to use different methods. Question A, you're going to want to eliminate, and you're going to want to do that by subtracting everything first, because you want three y's to cancel out. 2x minus negative 3x is 5x. 9 minus negative 6 is 15. When you divide the 5 on both sides, x equals 3. Then you got to choose which one of these top equations you're going to plug into. I'm going to choose the top one. It's going to be 2 times 3 plus 3y equals 9, and that means that 6 plus 3y equals 9. And by subtracting 6 from both sides, that means 3y equals 3, and that means that dividing by 3 on both sides, y equals 1. So 3 and 1 is the answer. Question B is going to be a substitution problem, because here we have x equals 8 minus 2y, so we're going to replace this x right there with its other name, 8 minus 2y equals 4. So again, those are exactly the same. All we got to do now is subtract everything. Be really careful on this one. Y minus 8 plus 2y equals 4, which means 3y minus 8 equals 4. When you add 8 to both sides, you're going to get 3y equals 12, and finally you can divide by 3 and get y equals 4. With substitution problems, the hard work happens on the front end. The back end is really easy. In this case, x is equal to 8 minus 2y, so 8 minus 2 times 4 is 8 minus 8, and so x equals 0 in that case, which makes sense. It works in both of the equations. 4 minus 0 is equal to 4, which is cool. Okay, now here on question C. This one is actually kind of interesting. There's a couple different ways to solve it. Honestly, you're just going to use substitution again, but you're going to use a special case of substitution called the equal values method. And it works like this. Since y equals a and y also equals b, that means that a and b have to be the same thing. In this case, a and b are these two expressions here. Negative 1/2 x plus 7 has to equal x minus 8. Now, that doesn't make the problem very easy to solve either, because we have to add 1/2 x to both sides. And depending on how you want to think about that, that's going to be kind of tricky. It's going to cancel out on the left side the way it normally does, and you'll have 7 equals. Now you have 1x plus 1/2 x, which you could call a number of things. I'm going to choose 1.5x minus 8, because I really want to think about this as 1 plus 0.5. At least think about these two numbers there. So from here, it's going to be pretty straightforward. You add the 8 to both sides, and you get 15 equals 1.5x. And if you know your decimals, you know the answer here is going to be 10 divided by 1.5. Or you could use a calculator, and you could just do 15 divided by 1.5 there, and you'll see the answer is going to be 10 for x. Oh, my calculator cam is kind of blurry. Once you get x equals 10, honestly, you just take this equation right there. Y is equal to x minus 8. So y is 10 minus 8, y is 2. The back half is really simple there. And over here on question D, this one is not going to eliminate nicely no matter how you look at it to begin with. But you should see that 10 and 5, although they're not the same thing, they're really close to the same thing. All you'd have to do is double everything on the bottom equation, and you would have a match there. So let's do that. Let's leave the top equation the same, 9x plus 10y equals 14. And let's multiply everything on the bottom by 2. It'll give us 14x plus 10y equals negative 6. Be careful, multiply everything by 2. And now, since we have the same sign, plus 10 and plus 10, we're going to subtract, kind of like we did in question A. You get negative 5x equals 14 minus negative 6, which is 20. Careful on that one. Then divide the negative 5, and you'll get x equals negative 4. Then let's take this bottom equation here. We know that 7x plus 5y equals negative 3. We'll go ahead and plug that negative 4 in for x right there. We'll get 7 times negative 4 plus 5y equals negative 3. Careful on your handwriting there, Ford. Negative 28 plus 5y equals negative 3. And now what we'll do is we'll add 28 to both sides, which will actually give us a multiple of 5. Because negative 3 plus 28 is going to give us 25. And when you divide by 5 on both sides, you get y equals 5, and you're good to go. There you go. Not so bad. Next question. Those four are kind of tough, but we're working through them. Next question, not too bad. For each line below, make a table and a graph. What do you notice? So I'm going to let the calculator do most of the work for me. This will be a good calculator review here for you. Desmos can also do this, but maybe it might be worth doing a calculator tutorial on this sometime soon. I'm going to go ahead and program 2/3 x minus 1 into the calculator, and I'm going to go ahead and just push second and the table button right there, and I'm just take a look at what the table is. Now I notice they're not nice whole number answers, but you know they are something. So I'm just going to go from -2 to 2 for this table. X and Y. Let's go -2, -1, 0, 1, and 2. And the Y values are -7 over 3, -5 over 3, 1, -1, sorry, -1/3, positive 1/3, and maybe one more just for good measure. 3, 1. There we go. I want that because I want these two whole number answers there. 0, -1. I know that points on the line on the graph. Oh, so let me get calculator cam out of the way. I'm actually going to graph it right now. I know that the y-intercept is -1, so I went ahead and put that point right there. The slope is 2/3, so I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. And that'll be the line, at least the first one at least. The red line is not, or the next line is not going to be as easy to do because this is in standard form. However, I think probably the best way to make this happen would be to actually solve it for y. Subtract 2x from both sides. We'll get -3y equals -2x plus 3, and then we'll divide everything by -3 to get them to cancel out. Oh, look what's going to happen. You're going to get y equals, well, -2 over -3 is 2/3, and then 3 divided by -3 is -1. Look at that. They're actually the exact same equation. 2/3 x minus 1. So they're the same equation. What do you notice? Ha! They are the same. So I want you to notice that these two equations are actually the exact same equation. If you wanted to graph the second one, it would just go right on top like that. Pretty cool. Next question, 473, got some absolute value equations here. Careful on these. Question A, I noticed right away, you might be tempted to split this into two equations right away, but you have to get the absolute value by itself first. So we're going to start by dividing by -2 on both sides, which cancels out this, and we're left with the absolute value of x equals 4. And this has two answers, because x could be 4, or x could be -4. Both of these have the same absolute value of +4. So remember, there's two solutions for these. Question B, for this, the process I usually use is take the inside of the absolute value and write it down twice. X minus 3.2, x minus 3.2. Put it down 2 times. And then we're going to make one of those equal to 4.7, and the other one equal to -4.7. We're going to write the same number twice, but one's positive, one's negative. And the inside stays exactly the same. All we got to do now is add 3.2 to both sides in both problems. Don't let the 3.2 confuse you. It just adds like any other number. 4.7 plus 3.2 is going to be 7.9 over there. And this is -4.7. Let me go to the calculator here. -4.7 plus 3.2, which is going to be -1.5 for the other number. Again, the answers don't really matter here. It's the process that you got. C is going to look very much the same as that other problem. Let's write down 9 plus 6x twice. Again, take the inside of the absolute value, don't change anything about it, and write it down 2 times. Put an equal sign after it. One of these equals 4. One of these equals -4. That's the pattern. From here, you're going to do the same algebra steps, so I think it's helpful to solve these problems side by side, like this. Start by subtracting 9 from both sides in both equations, like that. Subtracting 9 4 times. Cancels out, cancels out. What's left is 6x equals -5 over here, and 6x equals -13 over here. Now we're going to do the other same thing. We're going to divide by 6, divide by 6, divide by 6, divide by 6, because we want the 6 to cancel out, which it will do on both sides. And over here, the answer is going to be -5/6. That's the answer. Not nice, but that's what it is. Over here, the answer is -13 over 6. Those are the two solutions. They don't have to be nice numbers. And question D is going to have us do the exact same process one more time. Take the inside of the absolute value. And now this is attempting to get rid of these negative signs, but do not do this. You leave the inside of the absolute value exactly the same. Negative 7x minus 7 equals and equals. Keep it the same. Do not get rid of any negatives or subtraction. A 1 and negative 1 go down as the numbers they're equal to, like that. And now we're going to do the same thing. We're going to start by adding 7 to both sides. Moving all the numbers out that are not x. These cancel out, these cancel out. What you get is negative 7x equals 8 over here, and negative 7x equals 6 over here. And then again, we're going to divide by negative 7. Divide by negative 7, divide by negative 7, divide by negative 7. This cancels out, and you're going to get x equals negative 8 over 7 for the first number, and x equals negative 6 over 7 for the second number. The negative sign can be in front of the top number or the bottom number or right out in front. It doesn't really matter where you put it, but you do have to have a negative involved for the answer there. Okay, next question. 474, Amy thinks the solution is negative 4, negative 6. Eric thinks the solution is 8, 2. Who is correct? Well, all we're going to do here is we're going to plug these numbers for x and y and see if we get a correct answer. So let's check Amy first. So let's take the top equation and let's write it over here. It would be 2 times x minus 3 times y equals 10. We're just going to check to see if this works. So this would be negative 8 minus negative 18 equals 10, which is true. Negative 8 plus 18 is equal to 10. So that first one checks out. The second equation is 6y. Let's see, I'm going to write this right here. 6 times y, which is negative 6, according to her, equals 4 times negative 4 minus 20. Let's check this answer too. 6 times negative 6 is negative 36. 4 times negative 4 is negative 16 minus 20, and that is negative 36. So this checks out. Amy is correct. Let's check out what Eric thinks and see if we can prove it wrong, just to make sure we got the answer here. Let's talk about Eric. Let's try plugging in his answers of 8 and 2. 2 times 8 minus 3 times 2 equals 10. Let's check that first number. This is 16 minus 6, which does, in fact, equal 10. So the top equation checks out. Let's check the bottom equation. 6 times 2 is 12. 4 times 8 minus 20. Well, here we go. We got 12 equals. 4 times 8 is 32, and 32 minus 20 is also 12. Ooh. It's very possible they're both correct. Are these actually the exact same equation? Oh, check it out. So these are actually the exact same equation if you think about them for a minute. These both work out. They're both correct. The answer here is infinite solutions, and I'll show you why. I'm just going to do a little bit of work. You don't need to worry about this if you're watching this video. I don't expect you to do this, but you can. If you subtract the 2x from both sides, you get negative 3y equals negative 2x plus 10. Then if you multiply everything in the equation by negative 2, negative 2 times negative 3 is 6y. Negative 2 times negative 2 is 4x, and negative 2 times 20 is, or times 10 is minus 20. So these are actually the exact same equation. So this is what we mean by infinite solutions. They both work. Both people are correct. Because there's more than one point that works for this system of equations. Infinite solutions is the answer. 475, figure 3 of a tile pattern has 11 tiles. I'm going to write down 3, 11 for that. Figure 4 has 13 tiles. So 4 and 13. If the tile pattern grows at a constant rate, how many tiles will figure 50 have? Well, what we want to do is we want to think about this kind of like a table. It's probably the best way to do this problem. Since we're pretty close to 0 anyway. 1, 2, 3, and 4. Like, for example, we know that figure 3 has 11 tiles, and figure 4 has 13 tiles. So that means that we're growing by 2 tiles. So I know it's going to be, the formula is going to be y equals 2x, because we're going to start with that growth rate of 2. The question then is how many tiles did we start off with back in figure 0? So we kind of got to count back by 2, 9, 7, and 5. So plus 5 appears to be the case there. So the tiles seem to follow this pattern of 2x plus 5. So we want to know what's going to happen when x is equal to 50, the 50th tile. That would be 2 times 50 plus 5, which is 100 plus 5, or 105. And then some practice in 76 with a concept that you're seeing is actually still really important going forward. It's actually not too complicated either. We're going to solve these equations for variables. We're not going to get answers. We're going to get formulas since we don't have any numbers here. So let's start by identifying the target variable with b. We're actually going to subtract m times x from both sides in this first equation. And that's going to cancel right out. What you're going to have is y minus m times x equals b, which we've seen that formula before. B is equal to y minus mx. It's the same formula as mx plus b, just kind of backwards. Same exact target this time, but now we're solving it for x. So this time, since x is the target variable, let's get rid of that b first, and we'll subtract b from both sides. So this is actually a pretty easy process, but people get tripped up because they don't like the letters that are involved. But just leave them alone. Y minus b is y minus b. You don't know what y or b is, so you can't do anything with it. Then if I want to get x by itself, we've got to divide by m. And honestly, since we don't know what y or b or m is, I like that answer. Y minus b over m equals x. Call it a day. Question C, I is equal to P times R times T, and we're trying to solve for T. Honestly, all we got to do is get rid of the P and the R, and we can do that by dividing, because this is all multiplication in this problem. So let's divide by P and R. PR divided by PR will cancel out, leaving just T on that side, and I over PR is the correct answer. I don't know what I and P and R are, but that's what the formula would be for T. And then on question D, we got to solve this thing for T, which is right there. Let's start by getting rid of the little dangling P right there. We'll subtract P from both sides, which will make it A minus P on the left, and then P times R times T on the right. And now this problem looks a lot like question C. All we got to do is divide by PR on both sides, and we'll be done. And so T is equal to A minus P has to stay on top, divided by PR. And that's it. Nothing cancels out there, so that would be the final answer. Not too rough. Hey, thanks for watching. Hope you had a good time. I'll see you in the next video.